Hello, STATS class. These are the notes for 5.3b, which are about tree diagrams and the multiplication rule. We've done the addition rule. Now we're doing multiplication. Moved up, right? So specifically, tree diagrams are used when you have multiple events happening one after another. And I'll start with a simple example and then we'll get more complicated. So my first example is if we flip a coin twice. So we've done this before. We've done the probability of a head and a head, getting two heads in a row. And remember, when we listed the sample space, we had heads, heads, or heads, tails. I'm not going to list it again right now. But we found that this was 1/4 because there were 4 different ways it could come out, and one of them was two heads, and that's 25%. And I want to show you another way of looking at that. This actually comes from the fact that the probability of a head times the probability of the second one being a head is 1/2 times 1/2, which is 1/4. So that's your introduction to the multiplication rule. Generally, if two things happen in a row, you can multiply their probabilities, or you could see that really easily on a tree diagram. So here's a tree diagram of the same information. You might get heads or tails on the first flip. That's what this branch represents. And then on your second flip, you might get heads or tails, or down here you might get heads or tails. And since the coins are independent, as we've talked about before, the probability of heads and tails are both 1/2. And on the second flip, they're also both 1/2 and both 1/2. So that's like the simplest tree of all. We'll later do ones that are not 1/2, 1/2 all over the place. But that probability of a head and then a head, that's this branch right here. I'm going to use my highlighter. So if I'm talking about head and then a head, I'm talking about this branch followed by this branch, which is the heads heads thing, and it's 1/4, where it comes from 1/2 times 1/2. You can multiply each piece of the branch together. All right, so a couple more things we can get off of this. If you're going along a branch like that, talking about two events in a row, multiply. If you're trying to combine branches, you end up adding. So for instance, if I wanted to know this is heads, tails, and this is tails, heads, if I wanted to know the probability of one of these happening, or in other words, the probability of getting one head, and I don't care which one's first, I would add these two branches together. And we'll do that on some of our later problems. If I add all 4 branches together, this one, by the way, is tails, tails, I should get 100%. And this one's too simple, so I'm not going to do all the work on this one, but I could do each one separately and get 1/4, 1/4, 1/4, 1/4, and they would add up to 1. The fact that, here I'm going to use a new highlighter, the fact that these match these is how you can tell they are independent events. The fact that these probabilities are not going to change based on what happened in the first flip. Matching probabilities means they are independent events. Or vice versa. Since they are independent, that means they match. All right, let's do another example that's a little more complicated. If we always had 50-50, it would be boring and it would not teach you what you need to know about when it doesn't. So we'll do one more independent events example, and that's a traditional one with a bag of marbles. Back in the olden days in ancient Greece, they used to always say an urn full of marbles or something like that. We're going to just use a bag. It's fine. We don't have to have an urn. But in this bag, there are 3 black marbles and 2 white marbles. And we are going to start with that. It helps me to have the picture. And then for this next example, we're still going to do independent. So independent means I'm going to take 2 marbles out, but I'm going to put the first one back before I draw the second one. That's what makes it independent, because then the probabilities will be the same for each draw. I'm going to draw 2 marbles with replacement, which means I might happen to get the same marble twice, and that would be fine. With replacement just means I'm going to put the first one back after I look at it and write it down, and then I'm going to draw another one, which might be the same as the first and might not be. With replacement causes this to be an independent situation. And then we'll talk about what happens if you don't put it back. That's the third example. So here's my tree diagram. That's one of the things we're working on today. Black, white. Second draw might be black or white. Again, I could do more. I could have had 3 different colors in there, or I could do 3 different draws or something. This could get bigger. We're starting simple because I don't want to overwhelm you at the beginning. But let's put the probabilities on here. So since there are 3 blacks and 2 whites, the probability of black on the first time would be 3/5. There are 3 blacks out of 5, and 2/5 chance of getting a white. Then I take whichever one I drew first and I put it back. So now there's still 3/5 blacks and 2/5 whites. And that's, again, those matching branches tell us that it's independent. This time I'm going to show more work because these 4 branches do not come out equally likely. So let's practice our notation and practice the work you would have to do this. So this is the probability of black and then black. I'm going to write it this way, probability of black and black. And I'm going to come back and calculate it in just a minute. So probability of black and white. In this case, the and is implying and then, because I'm saying black first and then white. This is the probability of white first and then black. Sometimes that might make a difference which one comes first, so that's why I'm specifying it, but sometimes it won't. And probability of white and then white. And let's find all these probabilities. In fact, if you'd like to pause the video and see if you can find them on your own, that would be a great idea. In class, I might give people a minute to work on it. I'm not going to stop the video for that, but you can, and it's a good idea. So to find this black and then black amount, I multiply the 2 branches. I do 3/5 times 3/5. Little review of fraction multiplication. Remember, you multiply the tops, you multiply the bottoms. This does not reduce, so that's my probability of getting 2 blacks. Now I'm going to do black and then white, would be 3/5 and 2/5. Multiply them together. White and then black would be 2/5 times 3/5. Notice that's backwards of what we just did, but it's the same answer. It's still 6/25. And then white would be 2/5 times 2/5. So this time I'm showing work probably slower than you need because you're experienced people and you know that you can multiply and multiply and multiply. So we're just multiplying the fractions. If I add all of these together, I get 25 out of 25, which is 1. It adds up to 100%, which, as we learned in lesson 5.1 or 2, that's how you can tell it's a valid probability distribution. Here's the complete and disjoint list of all the things that could happen and their probabilities, and they add up to 100%. And then again, I could add 2 branches together if needed, depending on the situation. So sometimes I might want to know the probability of getting one of each, and then I would add these together, or the probability of getting both the same would be adding these 2 together. After you've found the branches, you can add them. If you have an or, probability of black and black, or white and white, you'd add those 2 together. All right, let's make it harder. All right, this is where it starts getting fun. So the independent events to me are almost too easy. These match and these match those, and it's like, oh, well, that's not very exciting. What if they don't match? That's where we're going next. What if they are not independent? And I didn't say dependent because, again, we're avoiding that word. In this one I'm about to show you, it would be dependent because what I'm going to do this time is I'm going to take that same bag of marbles and I'm going to draw 2 without replacement. And when I draw two without replacement, actually I'm going to pause.